Welcome to the first of our primary sessions for Protect Our Planet Day. Over the next hour, we will be investigating the Earth and its forests. Our forests are some of the planet's most precious ecosystems, and the way we care for our Earth is vital to protecting our planet. We'll examine the challenges these ecosystems face from climate change and discover the actions needed and those already taken place to protect them. You will learn from and be inspired by scientists working in the fields. I'm Sarah Dagnell and I work here at the STEM Learning Centre in York. I will be guiding you through the hour, introducing you to amazing people and showing you great activities which I hope you can join in with in your school or at home. Coming up, I'll be showing you an activity to explain the greenhouse effect, and we'll examine what exactly is meant by the term climate change. We'll then take a walk through the Earth's forests. There are numerous types of forest, and each is teeming with life. Despite this, they are sadly under threat, which has a devastating impact on our planet. You'll then meet a research scientist from the Centre for Alternative Technology, CAT. CAT are dedicated to researching the effects of climate change, and they suggest positive solutions for environmental change based on their research. You will learn more about the work that CAT do and find out about the relationship between forests and climate change. Deforestation is having a negative effect on the planet. CAT will then demonstrate one of these effects, how deforestation can cause flooding, but also how planting trees can help prevent flooding in the future. There will be a chance to ask CAT's research scientists questions to discover more about their job and how we can protect the Earth and our forests. So make sure you enter any questions that you have into the online chat, ready for me to ask during the live question and answer session. I'll be then talking you through a fun activity you can join in with in the classroom, looking at ways we can reduce and prevent localised flooding. But first, let's find out about the greenhouse effect and what exactly climate change is.
Hello, Paxi here. I bet you missed your favourite space explorer, didn't you? Today, I want to talk to you about something really important. Come with me. Can you see the thin layer surrounding Earth? It's the atmosphere. It contains the air we breathe, made of gases like oxygen. But it also acts as a protection to keep us warm from the deep cold of space and makes life on Earth possible. In fact, the atmosphere is like a greenhouse around our planet, keeping its temperature just right. Not too hot and not too cold. But what's a greenhouse? Greenhouses are those funny-looking houses with glass walls and roofs that you see in gardens and fields. They're called green because they're used to grow flowers and vegetables. Sunlight shines on the glass and warms the air inside, making it nice for the plants to grow. The glass also prevents the heat from escaping, keeping the temperature just right for the plants. Some of the gases present in the Earth's atmosphere, called greenhouse gases, work just like the glass roof of a greenhouse for your planet. They let the right amount of warmth from the sun reach the surface and trap some of it in, so that not all the heat produced by the sun goes back up into space. And this is what we call the greenhouse effect. But scientists all over the world are worried because the greenhouse effect is becoming too strong. The Earth is getting warmer and too fast, faster than at any other time in the Earth's entire history. But why? Come with me to find out. Human activity increased the amount of greenhouse gases in the atmosphere to dangerous levels, especially carbon dioxide. How? By burning oil, coal and natural gas for energy, by driving cars, by polluting the environment with factories, and raising huge quantities of animals for the food industry. Humans also cut down trees to build houses. or use the land to raise cattle or plant crops. This is also making carbon dioxide rise because trees are good at absorbing this gas and taking it out of the atmosphere. So the less trees we have, the less carbon dioxide is absorbed and the more of it we have in the atmosphere. All this carbon dioxide is making the greenhouse effect too powerful and increasing temperatures on Earth by trapping too much heat in. So, how can we fix this problem? Well, the good thing is that lots of countries are working together to change this and reduce the amount of carbon dioxide they produce. Another good thing is that you can help as well. Walk, jog, use your bike or skateboard to go places instead of getting a ride in a car. Don't waste clean water because it takes a lot of energy to produce it. Turn off your tablet, computer or the TV when you're not using it. Turn off the lights when you leave the room. Unplug. And last but not least, recycle everything you can. You can make a difference. So, today we learned that the greenhouse effect makes life on Earth possible. Human activity increased the greenhouse gases, especially carbon dioxide. This made the greenhouse effect too powerful, raising temperatures on Earth. Humans need to reduce the amount of carbon dioxide they produce. And there is lots you can do to help fix this problem. See you next time for our next adventure.
Paxi showed us how the greenhouse effect can help life survive here on Earth. I'm going to show you an experiment which demonstrates the basics of the greenhouse effect. It will help you to understand and see the effect it has on the temperatures on Earth. Here I have 2 transparent jars. At the bottom of each jar I've put a layer of soil. To that I'm going to add a few drops of water. Next, I'm going to attach thermometers to the side, being careful that they do not touch the soil. Now I'll cover one of the jars with cling film. This represents the Earth's atmosphere. And then record the initial temperature from each thermometer. The jars are now put somewhere sunny or below a strong warm light. You can record the temperature every 5 minutes for 15 minutes. This is what happens. You can see that the temperature of the air in the jar covered with the cling film is higher than the open jar. The cling film acts like the Earth's atmosphere. It lets heat in, but then blocks part of it inside the jar, so the air temperature rises. If the Earth didn't have an atmosphere, life as we know it would be almost impossible, as the average temperature would be seriously cold, several degrees Celsius below zero. The Earth has many elements, including our atmosphere, that make it perfect for life. Our forests in particular are teeming with it, and there are many, many different types of forest. This next clip shows you the beauty of the Earth's many forests, and I wonder how many types you can count.
Here we are in a mangrove forest in New South Wales, Australia. You can see behind me, we've got the grey mangrove, Avicennia marina. If you look around me as well, you can see that there's a bit of water sitting around, and mangroves are adapted to live in environments that are inundated by tides. They usually receive a tide at least once or twice a day. That makes the environment really inhospitable for normal terrestrial plants. But mangroves have these special adaptations that allow them to live in these more harsher environments. One of the key things they have is different root structures to allow them to live in the environment that's inundated and perhaps has a little less oxygen available in the substrate, or to deal with salt that comes in with tides. What we see in this case is we've got the grey mangrove with pneumatophores. These pneumatophores are much like a snorkel. So the tide can come in and the snorkel can stay out of the water for most of the time that the tide is in. Might be overtopped for a short period. They can hold their breath for that length of time, then the tide goes back out and they're happy again.
Do you know some tigers live in mangrove swamps? Surprising, isn't it? Yes, it is true, but not in all places, except like Sundarbans in India and Bangladesh. Sundarbans is also known as the world's largest continuous patch of mangrove forest. The ferocious big cat, Royal Bengal tiger, lives here in Sundarbans. I was told that local people who enter this forest wear a face mask behind to protect themselves from the big cats. The reason is very simple. As you know, tigers attack the prey from the backside. In fact, all tigers are not man-eaters. According to the villagers, they attack people in self-defense and less food due to increased tourism and deforestation nowadays. Tropical forests are distributed near the equator. They are rich in biodiversity and store substantial amounts of carbon, with amounts being greatest worldwide. They are, however, suffering from extensive deforestation and degradation and are increasingly vulnerable to fire and climate change. There are many efforts now to work towards their conservation and restoration, including putting the areas in protection.
Hi, I'm Dr. Peter Scarth, a University of Queensland scientist presenting from savannas in Australia. Savannas cover approximately 20% of the Earth's land area. They're a globally important ecosystem that provides habitat for thousands of highly specialised plants and animals, as well as a home for a quarter of the world's population. Savannas are a grassy woodland ecosystem characterised by the trees being sufficiently widely spaced so the canopy does not close, as you can see behind me. This allows light to reach the ground, supporting a layer of grasses. These nutritious grasses can support many large herbivores. In Australia, we have kangaroos and emus, and in other countries, savannas can support zebras, wildebeests, elephants, giraffes, ostriches, gazelles, buffalo, maybe even anteaters. They also support domestic livestock, like sheep, cows, and goats in many places. This grazing can sometimes cause the pasture to degrade and woody weeds to increase. Farmers and scientists are working hard to manage the impacts of grazing to stop this degradation and improve the condition of the savanna. Savannas are also distinguished by seasonal water availability. Most rainfall is confined to one season and they experience droughts and floods regularly. Climate change might alter the structure and function of the savannas, making them more susceptible to being degraded. Scientists are working in partnership with the people who live and work in them to understand these challenges and to develop methods to better manage these complex and interconnected systems in the face of all these challenges. Our global savannas have proven time and time again to be productive, resilient and responsive to all sorts of changes when managed well. I love spending time in these savannas and I love observing and understanding them. It's been great that you've been here with me today.
My name is Gut Sonnenschein and I'm standing here in a mountain forest in the Central European Alps. Mountain forests grow on almost all slopes and range from the valley bottoms up to the tree line where climate conditions are too harsh for trees to grow. Mountains are the water towers of our planet, and mountain forests are critical for the quantity and quality of our drinking water, not only in the mountain regions but far further downstream also in the lowlands. Mountain forests are also important to prevent soil erosion and to protect our infrastructure and buildings against natural hazards such as rockfalls, landslides and avalanches. Climate change is increasingly threatening mountain forests, and warming trends in mountains are twice as high as the global average. On the one hand, we see an increase of natural hazards, which is linked to the melting of permafrost. On the other hand, there's also an increase of extreme climate events, such as storm events, and both lead to the damage, but also loss of mountain forest.
Just wonderful. The Earth really is an incredible place. However, as Paxi demonstrated, humans have put more and more carbon dioxide into the atmosphere. When we heat our homes, drive cars and travel by plane, we burn fossil fuels such as oil and gas. This creates carbon dioxide, as does deforestation, which is when humans cut down trees in our forests. This has created a massive problem. The average temperature of the Earth has been rising. Although this might sound good because there'll be more sunny days, it's actually very bad for our planet. This changing climate means that we have more extreme and unpredictable weather. It causes issues across the Earth and affects humans and wildlife. This is climate change. Through the work of scientists, we can better understand climate change and look at ways to protect our planet Earth. Our forests are part of the problem, but also one of the solutions. Deforestation adds more carbon dioxide to the atmosphere, raising temperatures. However, planting trees in the right places and looking after our forests is one way that we can tackle climate change. The Centre for Alternative Technology will explain more.
Hi there, my name's Dr. Jane Fisher and I'm a lecturer and ecologist at the Centre for Alternative Technology. And we thought we'd take this opportunity to talk about the importance of woodlands and trees in helping to look after the environment. So we're going to look at the trees for three different things really, and look to see how it is that they help capture water and slow the flow of all that water that comes from rain, which helps to stop flooding. We'll look at how important trees are in holding on to carbon, and that's carbon that's taken from the atmosphere. And finally, we'll have a little poke around in the soil to look at where the carbon is stored, and also to look at all the things, all the different biodiversity we call it, which is all the little things that live within the soil, to see how diverse they are. So first of all then, just looking at this tree here, we've got a sycamore here, and you can see straight away that there's loads of branches, it's got a really interesting shape, and there's lots of texture. So if you look at the trunk's all sort of jagged and full of holes and pits. And if you look at these smaller branches here, and if you look close, you can see there's a little sort of greeny tinge underneath. And those are places where we've got different types of very small plants living. So there are small amounts of algae, which are tiny plants growing on the side of this tree. And also there are lichens, which are a mixture of a plant and a fungus growing together. So straight away the tree has lots of different things living on it, some of which are so small you can't see them very well. So what happens when it rains then? So when it rains, the water will fall onto the canopy, which are the leaves at the top, and the water will stay on the canopy for a bit, and then will start to drip through. And it will drip through and it will start to seep down all these little trunks and all these little sticks, and will take quite a long time. So when it starts raining and you go to shelter under a tree, you can stay dry for a little while, because it takes that amount of time between the start of the rain and then the water coming down and making you wet. So straight away that tree is slowing the flow of water. And if we squirt a bit of water onto some bits of tree here, we can see where it might go. So these bits here, you can see it flowing along the top. It's going into all the little nooks and crannies and then dripping down. Think of how different that would be compare it to a field which has maybe just got grass on it, and you've got cows maybe, or you've got a crop such as maize, or even at home, when the rain falls on the roof of your house or in the street, it runs straight off and straight into the nearest gutter or drain and then into the river. So that's one way in which trees help to slow the flow of the water between the rainfall and when it gets to a river. And because of all that slowing down, it means there's less flooding. So it's not just the tree itself that does that, but also the soil around the tree is really important. So here's a close-up of one of those branches then that helps capture the water and slows its flow. And on this branch you can see lots of things living here. You can see all these little differences in colour. Well, these little differences, these light patches, they're tiny lichens. So they are the little half plant, half fungi that live together on lots of different surfaces. And then if you look underneath, you can see like a powdery green. And that powdery green are tiny, tiny plants. They're microscopic. And they're also absorbing water. So all these tiny plants that live on the tree, which is a big plant, are also absorbing water and then releasing it slowly. And you can see here, because it's rained quite recently, so you can see underneath this branch here, we have a dry patch where the water hasn't got to yet. And the top part of the branch where it's wet, and that's where the water's flowed more slowly and eventually has made its way down to the soil. Okay, so now we've come down to the ground and we're going to have a look at how important the soil is. So first thing to say is the soil in a woodland is very powdery, it's very granular. It's a bit like holding onto sort of flour at home, and you can imagine it running through your fingers. And also if you look in this hole here, can you see tiny little hairs? And those hairs are small roots, and they're the roots of all the plants that are growing, not just the tree, but also the smaller plants like the nettles and the flowers and the grasses that grow in this woodland. So the combination of all those little roots and these nice small holes and sort of powdery type of structure, that also holds on to water. And if you think how much water you could soak into that ground compared to, again, a concrete surface. So it's like a sponge. We say these woodland soils, they're like a sponge. So if we look down at it now, you can see how deep this is, and you get your hands in, you can also see how dark it is. So this brings me on to talk a little bit about carbon. So you hear a lot about climate change and that being caused predominantly by a large amount of carbon dioxide in the atmosphere. And that's captured by these big plants here and turned into carbon. The tree is made of carbon, the leaves are made of carbon, everything that's living is made of carbon. And when the tree sheds its leaves, like it's doing now in the autumn, so we've got loads of leaves all around us, they're all also made of carbon. And because we live in Britain and the leaves are falling off every winter, all these leaves made of carbon are falling to the ground and getting turned into this lovely rich soil. And it's dark, partly dark because it's made of lots of carbon. And I just want to compare that to another soil that we've got here. So I don't know if you can see this white tray. So if you see this white tray here, we've got the woodland soil, which we've just put into this tray using a trowel. And we've also got soil from just next to this woodland, but this has come from a field where they grow maize, which is a crop. So this is a farmer's field where they're growing maize, which is sweet corn, in the field right next to this woodland. And you can see the difference. First of all, you can see how pale it is compared with the woodland soil. The woodland soil is really dark, and some of that darkness comes from all the carbon that's being stored. This field here is much lighter, so it's not holding as much carbon. The other things that are different about it, thinking about living things now and about what we call biodiversity, is if you look in this soil here from the farmer's field, it is powdery and there are roots from where the crop was grown, but there's not much living in here. Yeah? There's no sort of what we call invertebrates, which are insects and worms. But if we look at this soil here, you can see, yes, it's dark, it's also got lots of roots, but if we look in it, we can see, well, can you see there's a worm here? It's there's a little worm there all coiled up. Let's pick it up. So there's a worm. And also you can see some little shoots starting to appear. So they're from woodland plants that are beginning to grow. And also seeds. Got seeds. Do you recognise these? Helicopters that come down from the sycamore tree. And also, if you were to look really closely with a microscope, you'd see tiny, tiny microscopic animals living in here. And there'd be many more different types of microscopic animals living in here than there would be in this soil. So the other thing about woodlands is not only are they great for the environment, but they also make us feel really happy. It's lovely to go out for a walk, isn't it, and get away from your house and the streets and the sort of concrete environment we live in, and come into this woodland and look up at the trees, hear them swaying in the breeze, look at the sunlight passing through the different greens, and enjoy the sounds of nature. So just now we've heard a jay calling, we've seen some squirrels, and just being outside makes us all feel much happier and much healthier. So there's not much wildlife around right now, but maybe if we have a scan round, we can see what we can see. So if you see something,
Good morning, everyone, and I hope you're enjoying the Protect Our Planet Day so far today, and our Forest and Earth session. Welcome to all of the primary schools that are joining us. I see there's quite a few that have already been commenting in the chat, and please feel free to keep doing that throughout. We'd love to hear from you all. Now, unfortunately, we were set in this section here to welcome our expert from CAT, but unfortunately, I think they're out actually protecting our planet as we speak, because we seem to be having some technical difficulties getting hold of them. However, I'm going to do my best to answer some of these questions that I've seen that have come through from you guys. I have done a little bit of a search myself to answer some of these questions for you, and some of them I think I might be able to tackle on my own. So let's have a little think and look at what you've come and your questions so far. So we had a question that came in from Finley, and Finley is from Portlow Primary School. Finley had asked, when did we first become aware of climate change? Which I thought was an excellent question, Finley. Well, I had a little Google of this one because I wasn't actually sure myself when we first became aware of it. I do remember as a little girl it being talked about, particularly things like recycling. Blue Peter, which I'm sure that you all watch now, and I know that they're featuring in some of our secondary sessions today. They talked about recycling, and you would be able to get like 3 little magnets that you could go around and test your cans to see which ones you could recycle and which ones you couldn't back in those days. That's the first time I remember being aware of it. But when I did have a little bit of a Google, it actually turns out that even at the late 1800s, and I got the date of 1896, a first scientist actually published a paper talking about the fact that they thought that there would be problems with the Earth's climate. And then in 1938, a scientist actually started linking that to carbon dioxide, which we know is one of the problems behind climate change, as you saw Paxi mention earlier on in the video. But it wasn't until the 1950s that scientists became really concerned about climate change. And a lot of that was linked to a lot of the industry that humans had created, the fact that they were making things that were causing more carbon dioxide, the factories were causing more carbon dioxide, and they realized that there was a relationship between that and temperatures within our climate. And then into the 1980s was really when it started to become a real public thing, and we all became aware of this thing called climate change and started to change what we did and what we bought to help with that. And then it's carried on obviously to today, where we're really now trying to see that as a matter of urgency to change our habits to reduce climate change. So excellent question there, Finley. I'm glad you got me looking that up. Also from Portlow Primary School, we had a question from Aaron, who asked about what is the maximum temperature that the Earth can get before it dies, which again is an absolutely incredible question. And again, one I had to go and have a little look up for you. And I was really surprised by some of the facts that I found out, Aaron. So I found out that the Earth itself, I'm just going to go back to my research when it comes back up for me. The Earth's temperature on average is about 14 to 16 degrees Celsius, which is, I guess, like a nice spring day for us. It's kind of one of those days when we might put on like a little light jumper or a little light coat. It's certainly not winter times we put our big jackets on, and it's not summer where we'd be walking around in like little tiny t-shirts and things. 14 to 16 degrees Celsius is just nice. But it can get as high as 56.7 degrees Celsius, and that temperature actually recorded in Death Valley in the USA. So the Earth can get actually really quite hot and still support life. But it can also equally get really cold, and this is the fact I think that really surprised me. I saw that we can actually get down as low as 89.3, minus 89.3 degrees Celsius. I cannot imagine being in anything that cold. I mean, the amount of clothing that people must have to wear to actually endure any of those temperatures is just crazy. So the Earth is actually an amazing place in terms of the temperatures that it can sustain. But in terms of when we're talking about climate change, Earth's leaders and our scientists are really keen that we don't raise our average temperatures more than 2 degrees, and are really pushing for that to be 1.5 degrees. So we wouldn't be looking at those average temperatures getting higher than that rise, so 1.5 degrees Celsius rise. And there's lots of ways that we can try to help with that, to help with climate change and to bring that down, which is one of the other questions that we've had as well, about what little things can we actually do to help us to work on climate change in our everyday lives. So as everyday people, we can have a big effect on climate change and what we do. And that's through our habits. So thinking very carefully about electricity around the house. So if we're walking around a house and we've left a room, we can turn the lights off. When we're brushing our teeth, we can make sure that we're turning the water off in between actually wetting our brush and actually rinsing it at the end. There's all sorts of little bits and pieces we can do. We can be careful about how we travel, so we can think about maybe walking to school rather than taking the car. And we can think about doing things a little bit more sustainably. So we could think about maybe growing some vegetables at our house. We could think about buying fruits and vegetables that are from our local area rather than having to be shipped so far to us. We can think about doing things such as going to the shops and taking reusable bags rather than buying the plastic bags every time we do, because every time we buy a plastic bag, that has to be made. So that's causing more industry and more carbon dioxide. So things like that we can do to really help. Looking what other excellent questions came in from you guys. I loved this one actually. This was from Hickory class at Elmwood Primary, and they are doing an excellent initiative at the moment. They're all trying to create their own businesses, and some of the businesses are trying to be as eco-friendly as possible. So their question was, how can businesses help with the environment? Now, I think lots of the things that I've already mentioned, businesses can also do. So things like offering things like being careful with electricity. Lots of businesses leave their lights on overnight. So thinking about, no, people have gone home, we turn things off. We don't need to leave those on. Businesses can be thinking about where they're actually getting their goods from. Are they shipping them from somewhere thousands of miles away, or could they get them from somewhere a lot closer, which again is going to reduce that travel and reduce that carbon dioxide that we put into the air. Businesses could be thinking about their packaging and how they can make that as eco as possible. Could they use cardboard, paper instead of plastic? I mean, even better if we can avoid any packaging whatsoever. And in terms of the waste that they have, looking about how they can recycle as much as possible. I'm just looking again, see what other fabulous questions, guys, that you have brought into us. And I think our final one that I saw was, why are actually so many trees being cut down in the first place, which links us really nicely into the session that we've got about our forests and the earth. And there are lots and lots of different reasons why trees have been cut down. Some of it is for the timber itself, to actually use the wood, maybe for building or for making furniture. It can be for making paper, because paper actually comes from our trees in the first place, which is probably why your teachers often say to you things like, don't waste paper, you know, be careful with it, because each one of those pieces does come from a tree. Now, lots and lots of that over the years has been recycled as well, so we can find that we can use paper in more sustainable ways. It could be that trees are being cut down for farming and actually for the cows that we put into the fields, or the sheep. In some places, it's to create things like getting as much palm oil as possible. Now, palm oil goes into lots and lots of the food that you probably have in your cupboards at home, in schools. It's a really hard thing to not have around you, actually, because it's in all sorts, as well as foods. It's in makeups, it's in products that we might be washing with. So it's a really hard one to actually stop using. But because we use it in so many things, it's been found lots and lots more, and areas of forest have been removed to actually put palm oil trees there, so palm trees in place of the forests that were there before. Now, lots of those have become sustainable now, so they are they're not cutting down anymore, and they're looking at practice that makes that better for us to be able to use the oil without cutting down more trees and destroying our forests. But, you know, in other places that's not happening so much. So yeah, excellent question there. Just looking across, have we had any other questions come in, Josh? Or one or two extra? Well, let's just check what time we're on. Is there one more you can give me before we hand on back to the rest of the programme?
What is in plastic that makes it bad for climate change?
Oh, now that's a great question. What is in plastic that makes it bad for climate change? Do you know what? I'm going to be bad and say I'm not actually sure there. I know it's made from lots of different chemicals and oils and things like that, and those are materials that are really difficult to break down, and that means that if they go into the earth, whereas if you were to put something like a piece of fruit, if you put a piece of fruit on the floor, you'll see that it decays, it rots, it breaks down. And actually in a lot of cases those things become good for the earth because they help to feed it, you know, they actually go back into the earth, and then it creates nice soil for the earth to be able to use. But things like plastic, the materials that are inside those oils, those chemicals are really, really, really hard to break down. And we're talking hundreds, if not thousands of years for those to actually break down. And so for that reason, we need to try and reuse our plastics as much as possible, or try to avoid them as much as possible, so they're not getting into landfill and you know, unable to break down, because that would be horrible. Right then, guys, thank you ever so much for that. I am sorry once again that our real scientist from the Centre for Alternative Technology couldn't make it. As I said, I think they are out saving the planet. I'm going to let you return to the rest of the Forest and Earth session. Enjoy. Dr. Jane Fisher showed us just how important trees are, how important they are for the environment, and how they make us happy. Forests full of trees and other vegetation are essential for controlling the Earth's climate. They are a habitat for plants and animals, and they also help to prevent natural disasters such as flooding. Veronica and Helena from CAT will now demonstrate a deforestation activity which shows how the cutting down of our forests can impact on the earth.
Hello, my name's Veronica and I work here at CAT as the Biodiversity Engagement Ranger for the gardens, and this is Helena, and Helena is a garden volunteer. We're going to show you a simple deforestation activity today. So we've created 2 exact boxes. In this box we've created a mini woodland in the form of small broadleaf deciduous trees such as this oak, ash, field maple and a chestnut. Here's one of its leaves that have now fallen, and maybe you'd have some moss and some grass and basically vegetation. And trees and forestry and woodland in general are responsible for holding quite a lot of water. They can help slow down runoff and flooding, so slow down the water flow when it gets to the streams and the rivers and eventually the sea, and hopefully go some way to combating flooding. In this box you can see it's just soil, a few roots and stones. There isn't any vegetation at all, and this is what the ground would look like when you take out vegetation. So we're now going to demonstrate pouring water onto both boxes at exactly the same time, and you can see the difference in the water colour and the amount of water that comes out.
Thanks! I wonder, what do you think will happen? We'll return to Cat shortly to see the results of their flooding demonstration. But first, I'm hoping that you will join me in an activity provided by the Environment Agency that you can do at school or at home. It's a great way to see what can be done to protect towns from flooding. Climate change has made flooding more likely, and the flooding is getting increasingly worse. Imagine a hill running down to a town below. This ramp represents that hill, and the tub at the bottom is where the town would be. Here, I've got some marbles. They will represent the rainwater. This hill is bare. There's very little vegetation. No trees, no hedges, no grassy areas. In fact, the forest that was here was cut down for land for cows to graze on. What do you think will happen when I roll these marbles down to the bottom? Will they all make it? How quickly do you think that they will go? Let's find out. That took about 1.5 seconds. All the marbles got to the town at the bottom. If that was rainwater, that would be a lot for the town to cope with. It could cause flooding. But the Environment Agency used natural methods, among others, to combat this. Watch this clip to hear how.
NFM, natural flood management, is a more natural way of reducing the effects of flooding. It allows for new habitats to thrive and working with nature, not against it. NFM is a way to slow the flow of water using natural flood methods. On the coast, sand dunes and salt marshes are great ways of protecting the coast from erosion. Beavers have been reintroduced into some parts of the UK to help mitigate flooding. In Germany, they have beaver wardens to move the beavers if they start building dams in the wrong places. They are naturally and highly effective dam builders. Planting trees in the right places, ploughing fields in different directions, creating leaky dams are just a few of the ways of slowing the flow and creating natural flood protection. We have a biodiversity team who work closely with our flood officers to create NFM schemes.
Let's try some of these methods out using this ramp. I could use paper straws as trees, corrugated cardboard as a ploughed field, plasticine as rocks. I bet you can think of lots more possibilities. I'm going to put some of these onto my ramp. Now, what happens if I roll the marbles down the hill? This time, it took longer, and some marbles didn't even make it to the bottom. So, your challenge is to create a model of a natural flood management system for a town. Hopefully, you will have a ramp and some materials in your class to create your own system. You can then test it using marbles. If you haven't got the equipment in your classroom, Why not draw one on some paper or come up with ideas as a class? We'll give you time to complete the challenge. As you work, we'll show you some more images of our incredible forests.
Hi there, welcome to the Boreal Forest. So I'm going to talk to you about one of my favorite forested ecosystems because I am from Canada and I grew up here in the Boreal. These are forests that cover the very vast expanses of northern parts of the planet. So places like Canada, Siberia, Eurasia. These are cold on average, but there's a ton of seasonality. So really cold and dark in the winter, really bright and sunny in the summer. And they have a lot of really special adaptations to these northern latitudes. These are made up primarily of coniferous trees, like the spruce trees you see behind me, but also there's a lot of broadleaf species, things like birch and aspen. You have a lot of birds that will migrate from these forests in the summer back down to more southern places. Other animals that you kind of associate with boreal forests include bears, deer, moose, wolves, coyotes, and then of course a ton of birds. Those birds include owls, grouse, woodpeckers, and a lot of migratory birds. They do grow a lot slower than other forests, than other tree species that you would find in the tropics or temperate systems. But because they're so large, even a little bit of slow growth sequesters a ton of carbon out of the atmosphere and stores it both in the trees themselves, but also pumps it into the soils. But they're also very important in nature and people. So we use a lot of timber from boreal forests and other natural resources. These forests are under a lot of threat. So both from logging, we've been logging the boreal forest since people arrived in the boreal forest. And unfortunately, we're kind of shifting toward more sustainable practices there. But there's a lot of like mining activities that go on in parts of the boreal. And so we have to pay a lot of attention to making sure that these areas are being protected and that especially forestry activities going on are sustainable. Climate change is one of the most important threats to northern forests. So these places are heating up faster than anywhere else on the planet. We have heating up and drying out of these ecosystems. You have droughts, you have increasing fire, you have pests that can all of a sudden come up, like insects that can live at higher latitudes and attack the trees there. So there's a lot of disturbance. And because they're such slow growing forests, it takes a little bit more time. So we've got to be a little gentle with these forests. Climate change is also kind of interesting here because we're starting to see boreal forests shift further north. There's a lot of change going on in these areas. We are also seeing that there is an increase in sustainable forestry. Instead of like clear cutting an area, kind of thinning it out, taking the trees and using them for things like timber, but not in a way that degrades the quality of the ecosystem. So it's exciting to see a lot of the partnerships between commercial timber companies, environmental organizations, and indigenous peoples. And hopefully we will see a more sustainable boreal in the future. But researchers are also keeping a really close eye on these forests as they respond to climate change.
I'm Professor Richard Lucas from Aberystwyth University, and I'm here today to talk to you about the Celtic rainforest of Wales.
Celtic rainforests occur mainly on the western coast of Great Britain, in Wales, but also Scotland, England, Ireland, and all the way down to Europe. These rainforests are really unique. They were formed after the last glaciation, and they've been here ever since. They're also very diverse in terms of plant and animal species. This is because they live in areas where there's more than 3,000 millimeters of rainfall per year and the temperature is quite mild. They have this closed canopy which allows them to maintain the moisture content. This allows a large diversity of species of lichens, mosses and liverworts in particular to live here, and these communities are some of the most diverse in the world. There are also a wide range of wild animals that make this place home. These include polecats and also resident and summer migrant birds such as pie flycatchers, redstarts and wood warblers. And these come all the way from Africa every year to come and breed in these forests.
Celtic rainforests used to be far more extensive than they are today. Currently they occupy about 100 kilometres square, but they are confined primarily now to the steep valleys and the ravine that you see behind me. In the past they've been cleared for mining, to basically fuel the mines themselves, and also they have been replaced by coniferous and other hardwood plantations, primarily because these are more productive. Many areas have been lost to agriculture, for example for sheep grazing. A lot of hope for the future, and we really would love you to be involved. First of all, just by understanding these forests and recognising their value, that's really critical. Otherwise nobody's going to keep these forests into the future. Visiting them, exploring them, telling people about the value of something that's very precious to Wales and to the United Kingdom and to the world.
How did you get on? Did you manage to slow or stop some of the marbles? Let's have a look at my example. I added some furry fabric to represent reeds and long grass, some paper straws as trees in my forest area, a field ploughed horizontally so that the rainwater wouldn't flow straight across it, and some hedges which I made out of plasticine. Let's see what happens when I roll the marbles down the hill from the top. Wow, my natural flood management system has really slowed down the rainwater. In fact, some of the marbles didn't even make it to the bottom. That reduction in rainwater flowing down the hill could have stopped a devastating flood. The forest area was particularly helpful in stopping the marbles. Let's return to Cat to see how their demonstration is coming on.
The box without vegetation, you can see that the water's pouring out of the top pipe, which is the runoff pipe, and the box with vegetation, the water's coming out of the bottom pipe, and the water's a lot clearer. As you can see with this jug, the water came from the box with vegetation in. There's less of it and it's clearer, and the water that came from the box with just the soil in, there's a lot more of it and it's a lot muddier and darker. This jug demonstrates how having vegetation and trees and root systems helps to slow down the flow of water, lessening the risk of flooding, whereas this jug demonstrates runoff mostly, where the water came out of the top pipe, where it was falling quite heavily, where there wasn't any vegetation or root system, and therefore creating much more of a risk of flooding. If you'd like to find out how to recreate this experiment and have a go yourselves, then take a look at our worksheets.
We've seen how natural flood management systems, including forests, can help prevent or slow flooding. But in peatland areas, experts are working hard to restore waterlogged bogs rather than keeping water away. For a long time, peatland bogs were drained for farming or to make the collection of peat used for fuel to heat homes easier. However, peatlands capture and store carbon dioxide. Draining them releases that carbon dioxide into the atmosphere, which adds to the gases creating climate change. Peatlands are home to an abundance of wildlife, plants, birds and insects. Their restoration is important for ensuring the survival of this wildlife, as well as being a natural solution to climate change. Simon Gray from the Ulster Wildlife Peatlands team shared with us the process of the ongoing restoration of the Monagold bog. He also shares local tales of the peatland, which is at the heart of the local area.
Hi guys, I'm Simon Gray. I work for Ulster Wildlife as part of the peatlands team here. And I am today out on Monagold bog. It's a special area of conservation out in the wilds of West Tyrone, right out in the border between the UK and the Republic of Ireland. Ulster Wildlife is actually just kind of starting off on its peatland restoration journey. So we have been working for a few years now on a whole host of peatland sites, doing everything from rhododendron controlling other invasive species, monitoring ammonia levels, and blocking lots and lots of drains. But here on Moneygall, we have actually already installed hundreds of peat dams using huge 13-ton diggers, which we only got stuck twice, which was an absolute nightmare. But we got it out in the end, and we got all these peat dams installed, and they are raising the water table on this bog, and they're re-wetting the whole site, which is turning it from a carbon source into a carbon sink. But one of the really amazing things that we have done on our peatland restoration sites over the past few years is that we have talked to lots and lots of people and communities that live right around the edges of the bogs. So here in Ireland, bogs are magical places. They're so intricately tied to our heritage and culture here that you can't get away from them. Everybody that lives near or right beside a bog, they will have some sort of story that ties them to it. So what I wanted to do today was tell you just a few of the stories that the local people around Moneygall have told to us over the past few years that we want to make sure are remembered and are told to other people in years to come so that they're not forgotten. The main reason why bogs are so special in Ireland and so intricately tied to everything and everyone that lives around them is because whenever you dry peat out, you cut it and dry it out, you can burn it as a fuel. And that has been done by people in Ireland for hundreds and probably thousands of years. And here on Moneygall it was no different. So people from the local villages and towns like Castlederg, they came here during the summer months and they cut turf to heat their homes. But to do that they had to drain the bog, and whenever they drained it, then they weakened it. And that had severe consequences over 100 years ago. Whenever there was a night came with a huge deluge of rain, massive thunderstorm, and all this rain fell on the bog all at once, and because it was weakened by these drains, then its structure was compromised, and as a result it burst. Bog burst is a strange phenomenon, but effectively it's like the bog is a balloon and it swells with water until it can't hold that shape anymore, and then it literally pops. And there was a great story that one of the local people told us about a blind man who was walking down the road, and he heard what he thought initially was a thunderstorm, and then after a minute he thought that it was a drove of cattle. And so he thought, oh, I better get out of the way of these animals coming down the road, and he climbed up onto the bank, and the noise rushed past him, and he thought that this was just this herd of animals, but in fact actually this massive torrent of black peaty water, millions of gallons, rushed right past him. And thankfully the blind man escaped, but there was many others that weren't so lucky. It swallowed houses and barns and livestock all around Moneygall. And that story has actually gone down so much in history that there is a song about it locally. And we actually met a fella up the road called John Gallen, whose auntie, great auntie, actually was a first-hand witness of this event. And she wrote about it in her school books, which he still has today. So one of the other great stories that we heard from a local fella here at Moneygall was actually of a man who came to the bog to cut turf more or less every day during the summer when the weather was good. And he was like the alarm clock for everybody. He was here so regularly that anybody else that came to cut turf, whenever he lifted up his tools, put them beside him and went away for his lunch, everybody else did the same. But one day came along whenever he left early, and nobody really understood why. He didn't say anything, he just got up and left well before he usually would. And everybody was bemused, they didn't know what to do with themselves. It was like they had lost all sense of time. And after a few hours the man came back and everybody was perplexed. And they asked him where on earth he had gone. And it turns out, he said, I went away to get married. And he actually came back to the bog after he got married. I don't know many brides today that would be perfectly happy if their groom left them after the ceremony and went back to the bog to cut turf. But here, bogs were so closely tied to everything that we do that that was a perfectly normal thing to do. The last story from Moneygall here that I wanted to tell everybody about was of the last man that cut turf here. And he was still doing it when he was well into his 80s. And the Environment Agency here came out after the site had been designated as a special area of conservation. And they told him that he could no longer do this. They told him that there was too many species and habitats here that were so important that he couldn't cut turf anymore. And the old man put down his spade and he looked round and he looked back at these Environment Agency people and he said, "You've got to be kidding me. I'm the last thing alive on this bog. And unfortunately, in many cases, just like in Moneygall, that man's been correct. We've lost so many of the species that were so intricately tied to our culture and to the bog here. Everything from the curlew, the snipe, to even species like the large heath butterfly, which have disappeared in great numbers. And that's why we have such a job to do here. Not only to restore the bogs so that those species can come back, but so that people can continue to have a connection with something alive on these bogs going into the future.
Thank you for joining us for the Protect Our Planet Forest and Earth primary session. I feel sure that with the incredible work that scientists around the world are doing, like those at the Centre for Alternative Technology, we will continue to understand climate change and discover more and more ways to protect our Earth and its forests. But remember, protecting our planet is not just the responsibility of scientists. It's down to all of us to do what we can. Maybe think about walking instead of using the car. Many of us drive to school, but could we walk some or all of the way? This will help reduce our carbon footprint, which means that we are helping to reduce the effects of climate change. We can also be careful with the amount of energy we use at home and in school. Try turning off lights when you leave a room, or putting on a jumper rather than the heating when you feel cold. You can reduce, reuse, recycle. We need to reduce the amount of waste we create. We could buy products with less packaging or buy second-hand where we can. We can reduce food waste by planning our meals and not buying too much. Use reusable cups, bottles and shopping bags, and recycle wherever possible. Thank you to ESA and the Environment Agency for allowing us to use your fantastic resources. And a big thank you to the Centre for Alternative Technology for sharing your time and your expertise. I hope that you've enjoyed the last hour, and we'd love to see you again today. Coming up, you can join the second Protect Our Planet primary session, Ice and Oceans, at 11 o'clock. And we'd love for you to join in our Protect Our Planet Day STEM Club's hour at 3:30. Thanks for watching, and goodbye.